This is the notes page for transformations, and all on this front sheet you basically have a review of everything that we're going to go over. So I'm going to start on the back of page 1, and there are 3 types of transformations, and the first type is translations, and these are usually the easiest part. So I have here Desmos open, and I have, this is the x-axis, and I just want you to start out by just anchoring this. The x-axis is the left and right axis. You go to the left for the negative numbers, you go to the right for the positive numbers. Okay, so x you want to associate with left and right. And the y-axis is your up and down axis. You go down for the negative numbers and up for the positive numbers. So I want you to associate the y-axis for up and down, because everything makes sense. And if it doesn't make sense, then I will give you a way to remember it. Okay, so we're going to look at 3 different functions, because these translations and these transformations, the rules are the same no matter what type of function you have. Even if it's a function you don't really see that much, or you don't even know what it looks like, the transformation rules are going to be working the same way. So the first function is f of x equals x squared. Okay, and this is in function notation. This x is my input, and the rule is I'm going to, whatever I put in for x, I'm going to square it, and then out will come an output. Well, according to this note sheet, I want this function here to shift to the left 3. Okay, so this function, we'll call it g of x, I want to take it and I want to shift it to the left. So what do? Well, remember x is your left and right variable, so you can remember that whatever you do is going to have to be done wherever the x is. So this x is being squared, so I want to put a 3 in there with the x. Alright, now it says move left 3, so you might think, okay, let's do x minus 3 squared and see if it does the trick. Did that shift the function to the left 3? No, it did not. It did not shift it to the left 3, it shifted it to the right 3. So that's a little counterintuitive. What you have to do is, if you want to shift a function to the left 3, the vertex C is at 0, 0 here, and if you shift it to the left, that means the vertex is negative 3, 0 here. You have to actually do the opposite. So left 3, you're going to put a plus 3 in there. And what I just tell people is that the x's never play nice. They always do the opposite of what you think. So left 3 means you're going to add 3 to the function. But you can see why. If you put negative 3 in here for x, you will get 0. If you put x minus 3 in here, then your negative 3 minus 3 is negative 6. So you have to do the opposite of what you think. And like I said, I've got 3 different functions here. So let's look at f of x equals absolute value, so ABS of x. So there's our v. We'll turn these off. And if I want to shift this absolute value function to the left 3, well, what's the rule? I have to do the opposite, and it has to be in there with the x, so this is going to be absolute value of x plus 3. That moved that to the left 3. Okay, and then we have a square root function. Square root function, we use SQRT to get that typed in, and there's our square root function, and it's the first function that does not have a domain of all real numbers. Its domain is 0 to infinity. Well, if I want to shift this function to the left 3 based on the other 2, what would you have to do? Well, if you're moving it left and right, it needs to be in there with the x, and it's the opposite of what you think. So left, you would think minus, but nope, it's x plus 3, and that moves it to the left. Okay, so let's write that down. left 3, you're going to add 3 in there with the x. Okay. The function, the x is being squared here. It's inside that square. It's being taken the absolute value. It's inside this function absolute value. This x is inside that square root. Alright, so what do you think we would have to do if you needed to move these functions to the right 3? Or to the right 4, let's say. Let's turn all of these back on, these two back on, and these two on. Well, right 4, left and right's your x-axis, and the x's never play nice. So if we wanted to move it to the right 4, x minus 4 would work. If you wanted to move absolute value of x to the right 4, that would work. And if you wanted to put the square root function and move it to the right 4, that would work. Okay. So, just to remind you about the domain, let's look at this radical. So this domain of this green function, the radical is from bracket 0 to infinity, and when you shift it to the right 4, the domain becomes bracket 4 to infinity. Okay, so that's translations left and right. What if we want to go up 2? So if we want to take this quadratic and shift it up 2, which axis is the up and down axis? That's the y-axis, right? So we would not want to put the 2 in there with the x, right? We don't want that. And what we want to do is we want to put it outside the function. So the function is x squared. So if we want to move it up 2, we're going to add 2 to the outside of the function. So the y's, they make perfect sense. If you want it to move up, you add 2 to the outside of the function. If you want the absolute value to move up 2, we don't want to put it in there with the x. You want to add 2 to the outside of the function. Here we go. So if we want to take this square root and we want to shift this square root function up 2, right now that's moving it right 4. You want to add 2 to the outside of the function. So this underneath the radical is inside. This whole function f is square root of x, so the outside of the function would be adding 2 to the outside like that, and it shifts it up 2. Okay, so I'm going to write this down. Go ahead and think about what you'd have to do to shift down 5. Okay, so that hopefully you know outside the function. You're going to 5. The y's play nice. So get Desmos going. And there's too much to see here, so let's cut this off. Get Desmos going yourself and just explore. See how this is y equals x squared and y equals s squared minus 5. Moved it down 5. Here's f of x and g of x. The absolute value of v got moved down 5. And here's the square root of x. This time the domain didn't change, just the range changed. So it moved down 5. Okay, so definitely want you to do this one. See if you can get these functions to shift left 8 and up 2. So you can do 2 transformations at the same time. So if you want this parabola to move left 8, x is your left and right function, so you're either going to add 8 or subtract 8. Remember, the x's don't play nice, so we're going to add 8 inside the function, and that's going to shift it left 8, and up 2 we're going to add 2 to the outside of the function. So moving this left 8 and up 2, notice it's not too early to talk about the vertex of a parabola. See how the vertex of the parabola is 0, 0? When you move it left 8 and up 2, your vertex becomes negative 8, 2. So we're going to learn that later. You can see what the vertex is just by looking at the function. The vertex is negative 8, 2. You just have to remember the x's never play nice, so it's the opposite of what you see. Alright, if we want to move this absolute value function left 8 and up 2, we're going to add 8 inside that function and add 2 outside that function. And again, same thing. Absolute value functions have a vertex. This vertex is 0, 0. This vertex is negative 8, 2 because you've shifted it left 8 and up 2. Okay, if you really are good at understanding square root functions, this will help you understand domain and range. If you want the square root function to shift left 8 and up 2, this has a vertex of bracket 0 to infinity, and the range is bracket 0 to infinity. This square root function got shifted, won't let me keep that there, left 8 and up 2, so it's got a domain of negative 8, bracket negative 8 to infinity, and a range of bracket 2 to infinity. So you can kind of see what the domain and range is just like looking at the function. Alright. Okay, let's see if we understand this backwards and forwards. So look at these three functions and tell me what the translations are. What is this minus 6 inside the x minus 6 squared doing? What is the plus 5 doing? What is this minus 6 inside the absolute value with the x doing? What's the plus 5 outside doing? What is this minus 6 inside with the square root of x doing? And what's the plus 5 doing? So for all three of these, you should be able to say, well, it's moving the parent function right 6 and up 5. Yeah, I didn't mention that. These are called parent functions. They don't have any translations or transformations going on, so they're the parent, and anytime you do something to it and change the function in some way, those are the translated functions. Okay, let's move on to the second type of transformation that you need to understand, and these are called reflections. And we have the same three functions because it doesn't matter what type of function, these rules are going to be the same no matter what. And the first one is we want to figure out how to reflect over the x-axis. Okay, so this is my x-axis. Okay, and so if you want to reflect over the x-axis, I want you to think about this. Let's look at this point right here, this point 2, 1. Okay, if I want to reflect 2, 1 over the x-axis, then that's going to become 2, 1 is going to become 2, negative 1. So what coordinate changed? The x coordinate or the y coordinate? If I reflect over the x-axis, 2, 1 becomes 2, negative 1. So it's a little counterintuitive. If we want to reflect over the x-axis, the y coordinate is going to change. Okay, so what we have to do is if we want to change x squared, remember x squared, the x is inside the function because it's being squared. If I want to reflect over the x-axis, I need to change the y, so I need to multiply the y, or outside the function, by negative 1. Okay, and I wrote it like that so we could see it. Let's turn these on. See how that reflected over the x-axis, that -1 is not in there with the x because of PEMDAS. You're going to square x first and then take that answer and multiply it by -1. So you're really multiplying the y. So you need to multiply -1 outside the function to get it reflect over the x-axis. Okay, so let's see about absolute value of x. If you want to reflect that over the x-axis, you're going to need to multiply -1 outside the function. Not in there with the x, but outside the function. Let's turn that on. And it reflects over the x-axis. Again, if you want a square root function to reflect over the x-axis, you want the y coordinates to change. You want this 4, 2 to become 4, -2. So you're going to need to put a -1 times the outside of the function. It's not inside underneath the radical, it's outside, and it does. It flips it over the x-axis. Okay, so if I want to reflect it over the x-axis, I'm going to multiply outside by -1. So that's going to look like f of x equals -1x squared, or f of x equals -x squared. This gets people in trouble because they think that negative is with the x, but actually it's outside. Okay, so the -1 helps. This is a little easier to see because those bars are keeping that negative. It definitely looks like it's outside the function. And if you want to reflect square root of x over the x-axis, you multiply it by -1. Okay, so I'll let you, well, I'll sketch the graph so just so you can kind of see. Y equals x squared is, sketch it, looks like that has a vertex of 0, 0, and if you reflect over the x-axis, it looks like that. And then absolute value of x, it's good to do this so you can, it helps you memorize. Absolute value of x looks like a V, and when you reflect it over the x-axis, looks like that. And square root of x has a restriction on the domain. X can't be negative under that radical. Looks like that. And if I have y equals negative square root of x, it's going to flip that right over the x-axis. Okay, well, if we understand how to reflect over the x-axis, hopefully this will make sense how you reflect over the y-axis. Okay, and I'll just keep it right here with the square root. So this is my y-axis, and let's look at this point right here. If I want to reflect 4, 2 over the y-axis, isn't that going to become -4, 2? So the x coordinate is what needs to change. So if I want to reflect over the y-axis, it's the x coordinate that needs to change, so you're simply going to put a -1 in there with the x, and it reflects over the y-axis. Okay, now the other two are not so easy to see because they are symmetrical about the y-axis. Okay, so if I want to reflect x squared, turn these off, over the y-axis, there's already points over here, right? There's 1, 1 here, and there's -1 here, -1, 1 here. So when I do what I learned from the square root function and I multiply the inside of the function, or wherever the x is, I multiply -1 times x and then square it. See how it's inside? It's not gonna show up because the x squared function is already symmetrical about the y-axis. Same thing for absolute value. If I want the absolute value function to reflect over the y-axis, it's not going to show up, but I still can change the function. If I want to reflect over the y-axis, I'm going to multiply inside the function by -1. But it's not going to really change much because it's just reflecting on itself. So if I put these equations down, if I want to reflect this function over the y-axis, that -1 is being multiplied in there with the x, in there with the x, in there with the x. But graphing these, it's not going to really show up because this is y equals x squared and this is y equals negative x quantity squared. This is absolute value of x, and this gets reflected over itself is absolute value of negative x. This one, since it's not symmetrical about the y-axis, we'll be able to see it. This is y equals the square root of x. This is y equals the square root of negative x. And what's happening again is you have 4, 2 over here, and over here you have negative 4, 2. Put 4 in here. Right? The square root of 4 is 2. If I put negative 4 in here, negative of negative 4 is positive 4, and the square root of 4 is 2. So that works out. Okay, so we're going into the third type of transformation, and they are called transformations, and they involve vertically stretching or vertically shrinking a graph, or horizontally stretching, horizontal shrinking a graph. Okay, so I had to fix a typo here, but just take a look at these ordered pairs here. We have for f of x equals x squared, when x is negative 2, y is 4. When x is negative 1, y is 1. And when x is 0, y is 0. When x is 1, y is 1. You see these? When x is 2, y is 4. When x is 3, y is 9. So if I want to vertically blank something by a factor of 2, here's what you want to think of. Again, the y-axis is up and down. The x-axis is left and right. Well, you can also think of the y-axis. If you were to climb up that y-axis, you would be climbing vertically, right? And if you were to walk along that x-axis, you'd be walking horizontally. So if I ask you about vertical stretching or vertical shrinking, you're going to be thinking about what am I going to do to the y part of it, or the outside of the function. So if I want to vertically stretch this x squared by a factor of 2, factor means multiplication, so this makes sense. You're going to multiply the outside of the function by 2. And what's happening is, I said outside the function, but I also said you're changing the y. Well, look at the coordinates. Okay, so here is 1, 1 right there, and the new function is going to stretch and become 1, 2. So the x coordinate didn't change, but the y coordinate changed by a factor of 2. In other words, 1 times 2 is 2. All right, look at 2, 4. Here is 2, 4 from the original function. Look at what happens when you vertically stretch. It becomes 2, 8. So the x coordinate of 2 didn't change, but the y coordinate of 4 got multiplied by 2. So when you have a 2 multiplied outside the function, it's going to vertically stretch your function by a factor of 2. Alright, so what's happening is, you can think of it this way. You're taking these y coordinates and you're multiplying every single one of those y's by 2, but you're not changing the x's at all. So negative 2, 8, negative 1, 2, 0, 0, 1, 2, 2, 8, and 3, 18. Because if I multiply all of these by 2, I get this. Alright, so this is what happens when you put 2 times x squared. So same thing's going to happen with these absolute value. If I put a 2 in front of the absolute value and multiply, it's going to vertically stretch. So you can see that you're multiplying 2 outside. It's not in there with the x, so it's effectively changing the y coordinates, right? So if I take these y's and I multiply them by 2, I get negative 2, 4, negative 1, 2, 0, 0, 1, 2, 2, 4, and 3, 6. Let's see what it looks like when we graph it. So I want to vertically stretch my absolute value function by a factor of 2. So I'm going to multiply outside the function by 2, and see how it got vertically stretched. It's like I took that function and pulled it up. And look at the ordered pairs. So we have 1, 1, but now we have 1, 2. We have 2, 2, but now we have 2, 4. The y coordinates are changing. Same thing for the square root function. Get rid of that. And put 2 times the outside, and now I can see it got vertically stretched by a factor of 2. So that kind of makes some sense. We now have the point 0, 0. Well, if I multiply by 2, that's still going to be 0, 0. And we have the point 1, 1. Well, if I multiply that by 2, that's going to be 1, 2. Let's see if that worked out. Here's 1, 1. Here's 1, 2. That worked. We have 4, 2. Well, now we're going to have 4, 4. Yep, there it is. We have 9, 3. Well, now we're going to have 9, 6. So the y coordinates are changing by a factor of 2, and here's 9, 6 right here. 9, 3, 9, 6. So that's vertical stretching by a factor of 2. Alright, now what happens if you have a fraction? What if I want to do a vertical change by a factor of 1/2? Alright, let's just see what happens. So let's change that 2 to 1 divided by 2. Get rid of that. So the purple was the original function, and this parabola is 1/2 x squared. So if you look at the ordered pairs, look at this. This is negative 1, 1 and the original function, and this is negative 1, 1/2. So now the y coordinates are being multiplied by a half. So that means we call this a vertical shrink. I like to use it, the word shrink, or compression. That's a little bit more of a challenging word, but if this is less than 1, this factor, then it's going to make these y's go down by a half. So if I multiply all of these y's by a half, that's going to give me negative 2, 2, negative 1, 1/2, 0, 0, because 0 times 1/2 is 0, 1 instead of 1, it'll be 1, 1/2, 2, 2, and 3, 4.5, because half of 9 is 4.5. And so the same thing is going to happen for all of these. If I want to do a vertical shrink by a factor of 1/2, I'm going to multiply the outside of the function by a half, and I'll just type in 0.5. See how it vertically compressed it or vertically shrunk it? The y coordinates are changing. Same thing here. A vertical shrink. So vertical shrinks and stretch, I hope you don't find that's too difficult. We can practice really quick. If I wanted to vertically stretch a parabola by a factor of 4, then I would just put a 4 times, factor means 4, factor means multiplication, so remember you're multiplying to get these stretches, and it's outside the function. If I wanted to vertically shrink this function by a factor of 1/3, I would multiply outside the function by 1/3, and I vertically shrink it because the y coordinates are changing. Okay, if I wanted to flip it over and compress it by a factor of 1/3, I just put a negative in the front. So that's always easy to do. Okay, let's move on to the most difficult, and that is horizontal stretching or shrinking. And I wrote the functions over again here. And I wrote the x coordinates from the top of the page, negative 2, negative 1, 0, 1, 2, and 3. Okay, so a horizontal blank by a factor of 3. It's really tricky. So what's going on is we want to remember horizontal is your x, okay? And by a factor of 3, remember x's don't play nice. So in here I have 3, but I don't really need 3. I have to do the opposite, the multiplicative opposite of 3, which is the reciprocal of 3. So I'm going to be in there with the x. So in there with the x, but I need to do a 1/3 times x quantity squared. And look what that causes. See that purple graph? If you think horizontal, did it stretch or shrink? It stretched it. So when you have f of x equals 1/3 times x quantity squared, that is actually going to cause a horizontal stretch by a factor of not 1/3, by 3. So you have to look at that and say, oh, this isn't making it shrinking it horizontally. This is actually stretching it by the reciprocal. Okay, and it's kind of tricky. So let's look at these ordered pairs. So this ordered pair, let's start with -2, 4. So -2, 4 right here. Here's -2, 4. Let's look at this one. This is the point -6. So if I can make this a little bit better. This is the point -6, 4. See right here? Okay, look at this point -1, 1 right here. This new point is -3, 1. 0, 0 didn't change because we're talking about stretching and shrinking. All right, look at this point. Where is it? 1, 1. But now it's horizontally stretched, and this is 3, 1. That point right there is 3, 1. This point was 2, 4 right here, but now it's 6, 4. Are you getting the hang of what's happening? This point right here was 3, 9, but now with the horizontal stretch by a factor of 3, it's now 9, 9. Okay, so look at that. There's a multiplication going on in there with the x. The x's never play nice, so this is actually a horizontal stretch by a factor of 3. What that means is your x coordinates right here got multiplied by 3. -2 times 3 is -6. Your -1 times 3 is -3. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. But the y coordinates didn't change. So it gets a little tricky, the horizontal stretching and shrinking. Now that we've done that one, though, what would we do if we want to stretch the absolute value by a factor of 3? Well, horizontal stretch means you're going to multiply something in there with the x. By a factor of 3 means you're going to need to use the reciprocal. So the smaller the number here, the more stretching is going to happen. This one, if I wanted to stretch horizontally stretch this by a factor of 3, that would be square root of 1/3 x. So the 1/3 is going to go in there with the x. So let's see if I can make that bigger and do this. Okay, so if I want to horizontally stretch the absolute value by a factor of 3, I need to put 1/3 in there with the x, and it got stretched by a factor of 3. And if I want to take the square root function and stretch it horizontally by a factor of 3, I need to go and multiply the x's by 1/3. And that's hard to see, but it is a horizontal stretch by a factor of 3. Okay, so if I want to horizontally blank by a factor of 1/2, the reciprocal of 1/2 is 2, so this is going to be a 2 in there. That's how you're going to get your factor of 1/2. And this is not going to cause a stretch, it's going to cause a horizontal shrink. Okay, so let me put these numbers. I'm going to do it with the absolute value this time. Okay, so let's take a look at it. So if I want a horizontal shrink by a factor of 1/2, horizontal, okay, I got to remember it goes in there with the x. It doesn't play nice, so it's the opposite of what I see. All right, let's see what happens. Turn absolute value on. All right, I need to horizontally shrink this by a factor of 1/2. So 2 goes in there. And see that blue graph? It's got horizontally shrunk. Pushed those red values in by a factor of 1/2. Now take a look at your x values. 1, 1. It's kind of hard to see. We're talking horizontally. So 1, 1 is now 1/2 1. 2, 2 is now 1, 2. 4, 4 is now 2, 4. Okay, so what's happening is these x values are being multiplied by the reciprocal of 2, which is 1/2. Okay, so that is horizontal stretching and shrinking. Okay, let's take a look at the notes page and kind of see what this is going to help you do. So if you are adding a number outside the function, that's going to move it up. If you're subtracting a number outside the function, that's going to move it down. If you are subtracting a number inside with the x, that's actually going to move it right. If you are adding a number inside, that's actually going to move it left. All right, now these are your vertical transformations because you've got this number multiplied outside the function. That's like if your function is f of x equals x squared, then f of x equals 2 times x squared. That's what we mean by outside the function. Is going to vertically stretch it if c is greater than 1 and shrink it if c is between 0 and 1. So if it's a fraction like 2/3, it's going to shrink. If it's greater than 1, it's going to stretch. Okay, and then this is the last one and the hardest one. If there's a number multiplied in there with the x, it's going to cause a horizontal stretch or shrink. Okay, if p is greater than 1, it's actually going to shrink it by a factor of the reciprocal, 1 over p. And if p is a fraction between 0 and 1, it's actually going to horizontal stretch it by a factor of 1 over p because it's the opposite of what you see. So that's the hardest. And then reflections, if you have a negative 1 outside the function multiplied, it's reflecting over the x-axis. All right, if there's a negative 1 in there with the x, it's going to reflect it over the y-axis. So let's take a few minutes to practice this. So down here at the bottom, if you had this question, could you get it right? If you're given f of x equals the absolute value of x, can you write a new function, call it g of x, where this parent function f of x is going to be shifted right to, reflected over the x-axis, and shifted up 4. Okay, try that. So we got to follow the directions, we got to call it g of x. We're taking this function, this absolute value function, and we want to shift it right to. Did you remember that the x's don't play nice? So there's an x minus 2 inside. We want to reflect it over the x-axis. Did you remember it's the y coordinates that are going to change? So we need a negative 1 outside the function. And then we want to shift it up 4, so we want a plus 4 outside the absolute value. Okay, number 2. Given h of x equals x squared, write a new function, call it p of x, where h of x is shifted left 5 and it's vertically stretched by a factor of 2. Okay, so our new function is going to be p of x. The function is x squared, but we want to shift it left 5. So that means it's going to be x plus 5 in there with the x and then squared. And the vertically stretch by a factor of 2. Vertical stretch, that's y. Factor means times. So we're going to take a 2 and put it multiplied outside the function. And that's going to cause a vertical stretch by a factor of 2.